Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the water jet cutter water jet cutter episode 3. So here on my right screen, my second screen, we have the Trello open, and so we're going to talk a little bit about what we're going to do here. So let's say features. So it uses a core XY kinematic. Head moves the bucket, or I guess you could say the tank. Tank slash part stays stationary. At least a 24-inch by 24-inch, aka 2 foot by 2 foot cut area. Entire machine must fit in a 96 inches by 28 inch space. That's again the same as the mill, but obviously I want it to fit on the floor. It's about, let's say, tape measure in there? Oh yeah, I do. So let's see exactly how 2 feet, how big 2 feet is. 2 feet's pretty small. It's about the size of my printer. Yeah, it's about the size of this printer right here. I think if it was the size of how tall this printer is, I think that would be okay. Which it's about 2 feet by 2 feet. Oh, is it 2 feet by 2 feet square? It's taller. Yeah, it's a little bit taller, 2 inches taller. So let's say it was like square. Let's say that it was that square, that 28 square, or 29. I think this is actually 29. Oh, so what is that, 2.5 feet? Yeah, 2.5 feet. 2.5 feet tall. That's pretty cool. That's perfectly fine. And so that should fit underneath the table of the mill, right? And so we have the mill there, water jets underneath it. Everything looks good, because I still eventually want to have the mill. So okay, so, and then this is a 30,000 psi pneumatic pump, which I believe that's 500 to 1. So inputting 60 psi theoretically. Gives you 30k psi. And because this is not a what's the word I'm looking for? Because this is not a plasma cutter, you don't really have to worry about when you start cutting any sort of EMF coming and killing your controller. So that's the nice thing. So you don't need you don't need any optical isolators or anything like that. So then we have a blow-off valve and Arduino solenoid valve. To control low pressure side of the machine. Because I think the reason why a lot of people didn't do that is they're actually not using a compressor. They're using a compressor, but it's the compressor's inside of the machine, right? Because, you know, I am going to lose some efficiency, because if we look on here, I'm sure you would see that compressor. And I just saw a Husky, a really, really nice Husky that will probably have something like that. Oh. What else? Oh. Let's put that over here. Oh, let's say here 0.06 orifice and 20 thou. I'm probably gonna have to use 220 grit. Oops. Okay, so this one is, I want to have water recirculation. That's a very, very big one. And so garnet reuse, a garnet reuse system. So basically the idea is after every cut, you take the garnet out and then maybe even have a separate machine that you load this garnet into that will have some sort of smaller mesh in it, or so basically if it falls through if it doesn't fall through the 220 mesh, I can't remember, I think it's if it doesn't fall through the 220 mesh then it is 220, or if it, I think so, if it doesn't fall through the 220 mesh then it is 220. I don't know how high up they have to go. I mean, how far down they have to go to really narrow it in 220. I don't know what the specs are. But basically, I'm going to have a way of looking at these different garnets, and then have different meshes, and basically have a machine that goes through and kind of vibrates and with these meshes, almost like you see the mining for gold. So something like that where it shakes and then it goes through the garnet. The reason why, I mean, this machine is going to be a lot more efficient than the other machines as far as garnet use, because that's really one of the more expensive ones, especially with this one, how we have to use custom garnet, because not very many guys use 220 grit, and I'll show you how I came up with that shortly. So the idea, you have these like three different shakers, and if after like 10-15 minutes or whatever's on top of this shaker is good, whatever fell through is bad, and whatever got stuck on top is let's say whatever is on top is good. So then you could reuse it, reload it in. So the reason why that is that 20 thou mixing tube, let's say it doesn't spread out, because it will. Let's say it stays concentrated at that 20 thou. So I do have my caliper here. So what we could look at is how big the actual garnet is. Because the idea is that if that was the case, here's 20 thou is a really, really small orifice. So basically, when that guy shoots out, it's obviously gonna open up. It's gonna open up when it hits the material, the metal, in this case, and from there it will tell you what the what's the word I'm looking for? What the kerf is. So you cut the metal, and then that will tell you basically how far this material, this garnet is spreading after it leaves the orifice. So then what you go from there is you look at, so you shoot it, you look at the kerf, and then that's how much it's opening up. And then basically, if you had a circle, let's say you had a circle, right? So let's say that is your that is the projection of this nozzle opening up and hitting the material. Now, for example, here is your material, right? So obviously a very, very small material. So basically what's going to be hitting is the garnet about here, right? After the initial pierce. Let's say it pierces over here somewhere, right? Let's say it pierces over here and then goes over here to this section, right? Now, let's say it's cutting, so here is where it pierces the material, because the piercing is different, but it moves over here. At this point, the only garnet that's touching the material is this section over here, right? This is the only garnet that's touching the material. The rest of the garnet is shooting right down into the water where it's already cut the material. So basically, this is the cutting edge, right? And what part of a cutting end mill gets dull? It's the face of it, not the inside. The inside doesn't get dull. So you could reuse the inside. So let's say that you were somebody that had a grinder or whatever, and you were able to regrind. You could knock off the edge when it gets dull, and then regrind closer in. That's why they call them sharpening the end mill, right? It's only the edge that gets dull. So same deal here. So when this material hits the steel, this actually gets pulverized, the aluminum or whatever, or plastics or ceramics or whatever. So when it hits, this is the only material that I have highlighted there that gets pulverized and is no longer usable. Now, so the rest of this, that area that I scribbled there in the middle, up to that line, is just going to pass right through the material and hit maybe the slats, but go right into the water, right? And then most companies will, hey, stop, what are you doing? Stop it. My cat's freaking eating plastic off the floor. But it's all PLA, so I'm not too worried about it. Well, I mean, I am worried about it. That's a bad thing to say. Let me see. I pulled it out. I pulled it out of her mouth and threw it away. Okay, so yeah, so this material that passes right through is still good. This is still good material here, and that could be reused, right? And then put back in and form this arc here. So really, there are a lot of these guys. When my circle is going to be like that, their circle's like that, right? And same deal. But obviously, the percentage is higher of loss, right? Because basically, they're using like maybe 2 garnet thicknesses from the inside here. So 2 garnet thicknesses of, I think they use 60 mesh. So 1 60 mesh, 2 60 mesh, let's say, around their average. And then the rest of this is wasted, and usually it gets stuck on the bottom, and they have no way of getting it out with shovel. They usually have to get it out with a shovel, as far as at tech shop, or they dredge it. They have it full of water, and then they suck all the sand out. But and then the systems are very, very expensive because they're larger machines, and they have to process thousands of pounds of garnet. Now on this one, we have to process less than 20-30 pounds of garnet, and it will vastly decrease our cost per part for the shredder or whatever else that we do, and it will increase our productivity and everything like that. So obviously we're going to have other stuff in there. We're going to have more than just garnet. We're going to have metals and all that kind of jazz stuck in there. So that's why the idea of passing this material through multiple times to filter out the good stuff and the bad stuff. And then if we have metal flake in here or whatever, or aluminum flake or ceramic flake, shooting it at this is not going to be that big of an issue at the material. So basically that is the idea for that feature, is to save a lot of money there. Okay, garnet reuse system, water recirculation. So eventually I want to get a pump that does not use a compressor, very similar to the Protomax. So that would be ideal, that we don't need to use a compressor and we just have some sort of pump underneath and it just rock and rolls with that pump. Okay, so that's pretty much it. Let's see, major parts that still need purchasing. Oops. Flexible hosing. Intake manifold for pump. Exhaust manifold for pump. BOV for low pressure air side. And then for the gerbil, I have one right here with the A for whatever. So basically, we need these stepper motors and all that kind of jazz. Stepper motors, belts, pulleys, all that kind of stuff. And I do think that another thing I was thinking is I do think that Core XY would be helpful because we get to help a little bit with that pulsing, even though it's a dual action. So as it's shaking, this is going to hold it nice and strong. And then basically the entire thing will be made out of 2020 extrusion, just like my Tronc CX5SA here, and other machine parts. And then I'm still trying to figure out what I'm going to do with the tank. Probably initially it'll just be a plastic bin, right? So you just throw a plastic bin down there, and then when it, it's just got a hole in the bottom with or maybe not even the bottom, it's got a hole up floating at the top that has a little screen on it so that and then we're pulling fluid from it very, very slowly so that we can recirculate the water. And we can flow that down to a different tank and extract it from that tank so that we don't suck garnet up in there, because the 220 is going to be way lighter than 60 grit or 60 mesh, so it's going to have the tendency to float around quite a bit more than the 60. So but I think right now what we're going to start out with, as I showed you guys in the first episode, the guy used a galvanized steel washing bucket, but I think a plastic bucket filled with water is fine compared to the if it's full of water and also the water is hitting the steel and going through the steel first before it hits the water. I think we'll be fine. So those are the major parts. So let's go ahead and I do have a water jet cutter page opened. Let's see I guess what we could do, I guess we could just have two valves. We just have one valve here and then another valve open to atmosphere, but it has to be extremely fast. And again, this is just 60 psi. Yeah, so it's got quick attach. Let's say 0 to 0.8. Oh yeah. So we are in that area. I'm pretty sure that's what that says. Yeah, I'm pretty sure that's a 0.8. 12 volt. Yeah, so you're going to need to have I think this is for water. Hmm. It's 1/4 inch. Millimeters of mercury. Yeah, that ain't gonna fly. 6. Hmm. Exhaust valve to what? Oh, let's go here and then open. $50,000 times. It's too small. But what did it say that was? Exhaust air valve. Okay, well this is really nice. And put a flow meter on there. And also airflow meter. So water flow meter, air flow meter, air PSI meter. So maybe it will do something and then it will stop. Do something and then it will stop. Do a cut and then stop. If it figures out that the compressor is cycling or the PSI is starting to drop. I mean, I could do a Venturi, old school, change in pressure, blah, blah, blah. Yeah, this is a regular one. Oh yeah, it's definitely not going to be 30 liters. So yeah, I could do a Venturi. Yeah, so probably gonna have to build a Venturi of some type to figure out the CFM, and that will calculate how long it takes for the tank of the compressor to be depleted, and also how often it cycles and kind of all that stuff. So what it could do is that it could limit the speed or something that it is operating at, and thus give the compressor adequate time to cycle. So, for example, if it's going to start the next part has to start after a couple minutes of the compressor not being cycled, or let's say a minute after the compressor cycled, then it can start the next part, or 30 seconds or whatever. So something like that. Alright, so looks like we are past the episode 3 mark here at 32 minutes. So this has been Steven from Legit Tech Tutorials in the Green Ninja Years. Thank you guys for watching. If you like this video, please subscribe for more videos like it. I'll see you guys next video. Thanks for watching. Take it easy. Peace.